So we've discussed how a moving current generates a magnetic field, but what happens when a magnetic field induces a current? And so this is something that is described by the law developed by Heinrich Lenz, who figured out that if you have a changing magnetic field going through a loop, that will induce a current that will offset the magnetic field going through that loop. And so this can be tested in two different ways, but the bottom line is it will induce a current that exists to offset the changes. So one example is here. We have a loop or a coil here, and we're moving it over above a magnetic field. Notice that the X's here mean that it's going into the whiteboard, because it's often described as an arrow. If it's a dot, it's coming toward you. If it's an X, it looks like the feathers on the back of the arrow and it's moving away from you. And so here, when this moves over here, it starts as a loop with no magnetic field going through it, and then as the loop is moved, it then overlaps an area where the magnetic field is going into the loop in this way. What will happen is that will induce a current to offset that change. So moving through the loop, the current is going, the magnetic field is going inward, and you will see a current that is induced to offset that. And the way that that will happen is that the current will be moving in this direction. And by doing that, the right-hand rule dictates that when you're inside the loop, and I can draw this here, you have a current moving this way. The right-hand rule says that it will be coming towards you here and away from you there. And so that is the current that is generated, and that generates a magnetic field. So that's one example of Lenz's law. When faced with a magnetic field going into the loop like that, it will induce a current such that the current is fighting against the change, which is an increase of magnetic field going through there. Now, another example is with something like this. If you push a magnet through the loop rather than moving the loop like we did in this first example. If you push a magnet through this loop, it already started with some of the magnetic field going through the loop, but if it moves closer, that's going to be represented as an increase of magnetic field going through the loop. So if you're pushing it into the loop like this, that is going to increase the amount of magnetic field that is going into this loop here. And so what will happen is that will induce a current that will offset that by creating a magnetic field like this. And the way to generate that kind of magnetic field is to have it moving away from you like that. And so it's going in, and as a result, the magnetic field will look like this. It will come out on top, moving in that direction, and it will move inward. Notice that the part where it's moving inward is going to offset the increase in magnetic field that is going through this loop. And if we trace this all the way around, so we can trace this all the way around that loop, you'll notice that at any point along the loop, it's going to work such that we're going to have it go in here and then coming out this way. And notice that here, it's fighting the change in field. If we're down here, then it's going to be coming out through the top part, and so that's going to be coming towards us up here and going in like that. But the bottom line is that whenever you have any sort of change in the magnetic field, it will induce a current in that loop to offset that. So if we're moving this inward, that's increasing the field, and we'll do everything we can to get a field coming out that way. And the only way to do that is with an induced current and the right-hand rule. Now, if we were to take this magnet, instead of moving it inward, but instead move it outward, then what happens there is you're seeing a reduction in the field flowing through that. And so a current will be induced that will increase the amount of field going through there, because we're trying to offset the loss of magnetic field that happens when you start pulling that magnet away. So just realize that these are the two ways you're likely to see Lenz's law tested. Lenz's law can be tested by basically exposing a coil to a field, or by having a stationary coil with a changing magnetic field by either pushing the magnet into it or pushing the magnet away from it. And whatever happens, there will be a current induced, and it follows the thumb and curled fingers right-hand rule. There will be a current induced that can basically offset whatever change is happening with the magnetic field.